Well, hello, I'm Mr. Malden, and this is the Middle School Math Toolbox. Today, we're looking over the measures of central tendency. I just want to let you know, if you're new to this channel, I'm Mr. Malden, and in this channel, I teach you all about how to become a middle school math master. So if you're interested in that, hit the subscribe button down below. But let's go ahead and just jump right into this. And let's just talk about what a measure of central tendency is really quickly. And it is just a way to be able to describe what is typical. All right, so let's think about that word typical. What is typical? Typical is something that we can kind of like expect in life. All right, when we know things are typical, we know that they're kind of the same. All right, and it helps us to be able to kind of gauge what is maybe weird or different by looking at what is typical. All right, so typical helps us to know kind of what are the things that are the same and what we can expect. All right, so that we can be able to identify things when they are outside of the realm of what we expect. All right, so kind of just a way that we can start out with this is describing a typical seventh grader. All right, a typical seventh grader is probably 12 to 13 years old. All right, a typical seventh grader, you may fill in the blank yourself. What is a typical seventh grader? How does a typical seventh grader usually feel? What do they usually think? What are the different ways that we can describe a seventh grader? All right, just in general. If you had an alien that came from another planet and they wanted to know what is a typical seventh grader, you would use different descriptions to be able to describe to them what they could expect from a typical seventh grader. All right, so we like to know what's typical because we want to know what we can expect. All right, so that when we see something, if we came into a school building and the alien came into a school building or something, and they saw a 67-year-old person, they're not thinking that person's a seventh grader. They're thinking that person's probably an administrator, all right, or a parent or a grandparent or something like that. All right, so typical kind of helps us to know what we can expect, and we can also describe typical or what's typical, what we can expect using numbers. All right, I kind of started out doing that when I was describing the typical seventh grader, but you could use an age. As typical seventh graders in between 12 and 13 years old. All right, does that mean all seventh graders are 12 or 13-year old? No, some of them are younger, some of them are older, but by and large, most seventh graders are between 12 and 13 years old. All right, you could maybe use a shoe size. All right, typical seventh grader, I don't know, maybe a size 6 or a size 7. It's typical seventh grader is maybe around 5 foot. Typical seventh grader, maybe there's all sorts of different numbers that you can use to describe a typical seventh grader. All right, and that's ultimately what we're trying to do when we're finding measures of central tendency is we're just trying to discover what is typical and specifically using numbers. All right. So the words typical, we use the words mean, median, and mode inside math, all right, to be able to describe what's typical. And this unit, like broadly, is called data analysis, all right. We're going to analyze, or we're going to kind of pick apart and find out what the facts are of data. Data is numbers, facts, all right, facts that are in the forms of numbers, all right. Data can be other kind of facts as well, but in math, we're really concerned about the numbers. All right. So the words that we use to describe what's typical, there's 3 different ones. There's a mean, there's a median, and there's a mode. All right. So these are all measures of central tendency. All right. And we'll talk about what that word measures, or that phrase measure of central tendency, means in just a second. All right, but these are all different measures of central tendency: mean, median, and mode, which means they all kind of have like some similarities to them. They're all describing what the middle is. All right, or the central tendency. But they do it in different ways, all right? And that's why we have three of them, because we have 3 different ways to describe what's typical. And depending on the circumstance, one way might be better than another way, all right? But first things first, we just need to know what the ways are, all right? So let's start with a mean. A mean can be described as an average. All right, that's a synonym of the word mean. Average. It's the definition. But when you kind of think about it, when you flesh it out a little bit, it just means equal distribution. All right. So if I have this 5 rows of boxes that you see right there on your screen, all right, and I wanted to know a mean. All right. What I would do to these boxes, or one way to be able to find the boxes, was I could equally distribute these boxes in the rows such that each row has the same number of boxes. And if I did that, all right, if I equally distributed these 5 rows. Now, none of the 5 rows have the same number in them, but if I equally distributed all the boxes, I would find out that there would be 4 boxes in each row, and therefore the mean, or the average number of boxes that are in each row, would be 4. All right, I'm just equally distributing the boxes to the number of rows. That's what a mean is. And this is probably one of our world's, or probably is, anyways, it's one of our world's favorite ways to be able to describe what's typical. It probably is the favorite way, is what I was trying to say. All right, is just to find an average, which we could take and we could do it the long way by equally distributing each of these numbers, each of these, in this case right here, the boxes and the rows. But the quicker way to do that is just to simply add up the numbers. So you need to get the sum of the number of data points, all right? So in this case right here, you have 7 boxes in this row, plus 3 boxes in this row, plus 1, plus 5, plus 4, all right? When you add up all the boxes, there's 20 boxes total, all right? Then we're going to take that total number of boxes and we're going to divide it by how many rows there were, all right? How many data sets there were, okay? So you've got 1, 2, 3, 4, 5 rows, all right? So you're going to take that 5 and you're going to divide 20, that's the total number of boxes, by the 5 rows to find out that there would be 4 boxes in each row if we equally distributed all of them. Right? This is the quick and easy way to find a mean, an average, is to simply add up all the numbers and then divide by how many numbers there are. All right? So here's kind of some definitions for you. If you want to pause and you want to write those definitions down, you can go ahead and do that. But a measure of center is a way of just summarizing data by providing a central point of data. All right? We want to know what is the center. All right? And one of the ways to find out, or one measure of center, is a mean. And that's simply an average of the data taken. And you find that by collecting the sum, that's adding all the numbers together, and then dividing it by the number of data points. All right? How many data points did you have? That's what we're going to divide the sum by. All right? And this is essentially helping us find a fair share. All right, if every row had a fair share of boxes, how many boxes would be in every row? There would be 4 in that example that we just looked at a while ago. So why don't you go ahead and try this one? All right, the list below shows the shoe size for 8 students in Mr. Perdito's class, and we want to find ultimately what is the mean, what is the average. If we equally distributed the shoe sizes amongst all the students, all right, what would the average shoe size be? So the first step that you need to do, by the way, go ahead, if you're new to this channel, what I like to do is give you examples and then give you an opportunity to pause the video, to try it yourself, and then to come back, unpause it, and see what the right answer is. So if you haven't tried it yet already, why don't you go ahead and pause it, try it, and then come back to see what the correct answer is. All right, so to find the mean, the first step is to simply add all the numbers together. And if I added all these numbers, these 8 numbers together, 13 plus 12 plus 9.5 plus 10.5 plus 12 plus 11 plus 12 plus 8, I would come up with 88. All right? And then the second step is to take that sum and divide it by how many data points there are. There's 1, 2, 3, 4, 5, 6, 7, 8. All right? There's 8 data sets. All right? So we're going to take 88 and we're going to divide it by 8, and we would find out that the mean, or the average shoe size, is 11. All right? So there you go. A mean is one way to describe a measure of central tendency, all right? And or is one measure of central tendency. And the way to find that is to add all the data sets together and data points together and divide by how many data points there are. All right, why don't you try this one? All right, pause the video, come back and see what the answer is. All right, the sum for all these numbers, which if we're trying to find the mean, the following data represents the age of people in line to vote. We want to know what the average age is for each person. All right. The first thing we're going to do is add up all the ages together. And the second thing we're going to do is we're going to divide by how many numbers there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we're going to take 490. That's what we get by adding all those numbers together. And we're going to divide it by 10 to find out that the mean age is 49. All right. Of these people who are standing in line, all right, the typical person is about 49 years old. All right, that's one way to describe it. All right, if we equally distribute all their age, that doesn't mean that everybody's 49. It doesn't mean that even one person's 49. It just means that's the measure of central tendency. That's what's typical for this group, right? And then you can compare the rest of the ages relative to that. This person that's 27 years old is quite a bit younger than the average, all right? And this person that's 68 is quite a bit older than the average, all right? The average, the middle, is about 49, all right? And so the closer you get to that, the closer you get to being typical. All right. This is another way that we see data listed, all right? So in these videos, in this unit, you're going to see a lot of different data representations. But this is a frequency table, all right? And it's a frequency table for this question or for this scenario. The following data set represents the number of minutes callers have to wait for a service technician with a call Netflix, all right? So if you had a problem with Netflix, you called up to get some service, this table right here tells you, the experience of a number of individuals, of how long they had to wait, so they can help you kind of determine what's typical, all right, or what can be expected. How long will you end up waiting on the phone on Netflix before you get a person, right? Well, in the table, it says that you had the number of minutes. Some people waited 4 minutes. Some people waited 5 minutes. Some people waited 6 minutes. No people waited 7 minutes. Some people waited 8, and some people waited 9 minutes, right? So this is just the value of the data points. The data points are actually these little tick marks down here, all right? So this box right here that has 1, 2, 3, 4, 5 tick marks, all right, tells us that there were 5 people who waited 4 minutes, all right? And then the one here says there's only one person that waited 5 minutes. Then there's only 2 people that waited 6 minutes. Nobody waited 7 minutes. One person waited 8 minutes. 3 people waited 9 minutes, all right? So if we had all these data sets, the first step that you want to do when you've got a frequency table is just list out all the data points, all right? Since I had 5 people who waited 4 minutes, then I have 5 4s, all right? And if I had one person that waited 5 minutes, I just have 1 5, 2 6s, and 1 8, and 3 9s. So the first step you want to do is list out all the data sets or the data points, okay? Then to find the mean, you want to simply add those together and divide by how many numbers there are, all right? There's 12 numbers, so 72 divided by 12 is 6. The average wait time is about 6 minutes, all right? Which is pretty cool because that kind of shows you that 6 and 7, that's about the middle right there. The average wait time was 6, so yeah, that kind of tells us what's typical, what we can expect. When we call in to complain to Netflix or to solve an issue, all right, you're going to wait on average about 6 minutes for that phone call before another person answers the phone, okay? That's what a mean is an average, an equal distribution. All right, let's go to the next one, median. The mean is probably the most tedious to find because you have to do quite a bit of math. You have to add all the numbers and then divide by how many numbers there are. It's not real hard, all right? It's just tedious. It takes some time to sit there and press in all the numbers in a calculator or just to add them up long form, all right? The median is a really easy number to find, all right? Let's first just understand what the median is. It is the middle number. So literally, if we lined every number up from least to greatest, what number's in the middle, all right? So the first step for finding the median or the middle number is the same first step for just about anything in data analysis, and that is to list the numbers in order from least to greatest. If you don't do that step, you're not going to get the right answer when it comes to the median, all right? You have to. The very first step is to take your numbers, all right, to take your data points and list them in order from least to greatest, all right? Then you're going to go try to find the middle number. Now, there's a little trick to this, though, all right? It can be a little tricky, all right? Some data sets they have an odd number of data points, right? So each one of these is a data point. 7, 3, 1, 5, and 4. You see those data points right there? This row had the 7, that row had 3, that one had 1, so on and so forth, all right? These are each data points, all right? We want to list them in order from least to greatest. And when we do that, we find out we have 5 numbers. We have an odd number of numbers. We have 5 data points. If you have an odd number of numbers, then the number there's going to be just one number in the middle, right? Whatever that number is in the very middle, that is your median, all right? So it's not a very hard number to find, all right? It's just the number that's in the middle. And when you have an odd number of data points, it's the one number that's in the middle, all right? And the simple way to be able to do this, this is how I do it a lot, all right? If I listed the numbers in order from least to greatest, just like this, all right, on my scratch sheet of paper, the way to find the number that's in the middle, now this one's a really small number, so it's really pretty easy. You can simply identify what it is. But if you had a lot of numbers, then the way to do this is I would scratch off the first and the last, so 1 for 1. If I scratch off one here, I've got to scratch off one there. And then in the next first and the next last, all right, until I come down to 1 or 2 numbers in the middle, okay? If it's an odd number of data points, there will be 1 number in the middle. If there's an even number of data points, like we'll see in an example here in a second, there will be 2 numbers in the middle, right? If there's an odd number of data points, which means there's only 1 number in the middle, the median's really easy. You just take that number, all right? It's a 4. All right, so the median here for this example that we're looking at on our screen is 4, okay? But if we have an even number of data sets, all right, so we have kind of a similar situation. Right now we had 5 rows of boxes, but now we have 6 rows of boxes, which means we have 6 data points, all right? If we have an even number of data points, then once we list them out least to greatest and we scratch off the first and the last to come down, we're going to come down to 2 numbers that are in the middle, all right? So again, I'm going to list these in order from least to greatest. And then I'm going to use my little scratch method to be able to find out which number's in the middle. I know there's 1, 2, 3, 4, 5, 6 numbers. That's an even number of data points. And since there's an even number of data points, I know I'm going to come down to 2 numbers that are in the middle. So I'm going to scratch off the first and the last, the next first and the next last. And now I come down to 2 numbers that are in the middle. If you have 2 numbers that are in the middle, all right, after scratching the first and the last, and the next first and the last, the next first and last, then we can come to the 2 numbers. If you have 2 numbers that are in the middle, then you want to take those 2 numbers and get an average of those 2 numbers, all right, which means add the numbers together. So 4 plus 5 would be 9, and divide by 2. All right, because there's 2 numbers right there. We want to find an average between these 2 numbers, so you get a sum of them, and then you divide by how many numbers there are. There's 2 numbers right there. All right, so 9 divided by 2 would be 4.5. So in this case right here, the median is 4.5. All right, let me go ahead and I'll make that a little bit bigger. All right. Again, you had an even number of data sets. We scratch off the first and the last until we came down to 1 or 2 numbers in the middle. Because there was an even number of data points, we came down to 2 numbers in the middle, all right? And then we're going to get an average of those 2 numbers. So add those 2 together and divide by 2. You get 4 plus 5 is 9, divided by 2 is 4.5, all right? That's how you find the median for an even number of data sets, all right? Okay, here's a few more notes. If you want to pause the video and you want to write these down, you can go ahead and do that. But a median is a measure of center that describes the middle. It's probably the easiest number in data analysis to find. List the order of the numbers from least to greatest, and then literally find what's in the middle. If there's an odd number of data points, there'll be one number in the middle. If there's an even number of data points, there'll be two numbers in the middle. If you find two numbers in the middle, then you want to add those two numbers and divide by 2. That's a mean. That's an average of those two numbers, and that's going to be your median. All right? Go ahead and try this one. All right? We had the same example for the mean, which I think the answer was 11. All right? The average shoe size was 11. All right? Now we need to find out what's the median. All right? So go ahead and pause this video, try it yourself, and then come back to see what the answer is. Okay? All right, the first step in this is to order them from least to greatest. So I'm going to take the 8, that's the least. Then I'm going to take the 9.5, then the 10.5, then the 11. Then there's 1, 2, 3 12s, and then a 13. So I'm going to list out all the 12s, not just one of them, all of them. List out all the data points, all right, in order from least to greatest, all right, which is a little tedious. It takes a little bit of time, but it's not hard, all right? And if you don't do that step, you're not going to get the right answer. So be sure to list out all the data sets in order from least to greatest. Then find out the one that's in the middle. Now, in this case right here, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers, which means that's an even number of numbers, all right? Which means I'm going to come down to 2 numbers that are in the middle. I'm going to take those 2 numbers, add them together, and divide by 2. All right, the ones that are in the middle are 11 and 12. Because if I scratch out the 8 and the 13, the 9.5 and the 12, the 10.5, the next 12, I'm going to come down to 11 and 12 in the middle. All right, and I'm going to add those 2 numbers together. That's 23. 11 plus 12 is 23. Divide by 2, and I find my median is 11.5. So in this data set right here, all right, the median shoe size is 11.5. All right, so we found out earlier that the mean was 11, the average is 11, but the middle or the median is 11.5. All right, and these numbers are really close to each other. You can probably see now why they're both called measures of central tendency. All right. Try this next one. I want to know what the median is of the data that's listed out right there. So go ahead and pause the video, try it yourself, then come back to see if you got the right answer. Right? First step is to order them least to greatest. Then I'm going to count my number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 numbers, which that's an odd number of data sets or data points. All right? Which means I'm going to come down to one number that's in the middle. It's going to be really easy, all right? Scratch off the 33, the 72, the 38, the 68, the 41, the 60, the 41, and the 57. And I come down to one number that's in the middle. That's a 42, all right? And so that's my median, all right? It's that easy. If you come down to one number in the middle because you have an odd number of data points, that's your median. If you come down to 2 numbers in the middle because you had an even number of data points, then you take those 2 numbers, add them together, and divide by 2. That'll be your median. All right? Let's try this one. Go ahead and pause the video and try it yourself, then come back. All right, first step is to order them from least to greatest. Then I'm going to have to go and I'm going to have to scratch off the first and the last, the next first and last. So I'll come down to 2 numbers in the middle. The reason I have 2 numbers in the middle is because I have an even number of data points. There's 12 data points, all right, which means that's an even number. I'm going to come down to 2 numbers in the middle. The 2 numbers I come down to are 5 and 6. All right, so if I add those 2 together, that's 11 divided by 2 is 5.5. So the median in this case is 5.5. All right. So we've done mean, that's an average or equal distribution. We've done median, that's a middle number, all right? And the last one is mode, all right? So we have mean, median, and mode as measures of central tendency. And this one's probably the next easiest to find, the mode. It is just the most repeated, all right? Not the greatest amount, but the number that is repeated the most, all right? So if I have 6 rows of boxes right here, and one row has 5, the next row has 7, then one row has 3, and another row has 1, and another row has 5, and another row has 4, right? I want to know which data set was repeated the most, or which data point was repeated the most. So again, the first step, all right, for everything other than a mean, all right, is to order your numbers from least to greatest, right? So I'm going to take my numbers of boxes in each of the rows, my data points, and I'm going to order them from least to greatest. So in this case, 1, then 3, 4, 5, 5, and 7, all right? Once I do that, it's really easy to determine what number repeated itself the most, all right? The mode is the most repeated. So it's not the greatest value, it's the number that's repeated the most. And in this case, you have 5 repeated the most, all right? So 5 is the mode, right? Just like that. If you have maybe 2 numbers that are both repeated the most, they're tied for first place and being repeated the most, then they're both the mode, all right? If all the numbers are different, all right, so no number is repeated, then there is no mode, all right? So mode just means the number that's most repeated. So why don't you go ahead and try this next one, all right? See if you can find out what the mode is. Then come back and see if you got the right answer. All right. Again, first step is we want to list these numbers in order from least to greatest. Now, there is an even, I was about to say there's an even number of data points, but that's not relevant for the mode. That's only relevant for the median. So forget what I just said. All right. The mode is the number that's most repeated. All right. And the number that's most repeated, once you order it from least to greatest, it's really easy to see that 12 is repeated 3 times and no other number is repeated. So 12 is the mode. All right. Let's try this next one. All right, again, pause the video, try it yourself, come back to see what the right answer is. All right, we're going to take this, we're going to order from least to greatest. And then once we do that, it's really easy to see that 41 is repeated twice and no other number is repeated, so 41 is the mode. All right, and last one, last example. The number of minutes for contacting Netflix that you have to wait on hold. It's really easy to see from this frequency table what the mode is. That's the one that has the most number of individuals who represented it. All right. So you had 4 minutes and you had 5 people who waited that 4 minutes. Everybody else was less than that, or every other number was less than that. So 4 is going to be the mode. But again, step by step, the way to do this, first step is to order everything from least to greatest. Then it's really easy to see which one is repeated the most, all right? The one that's repeated the most is 4, okay? Let's pretend, just pretend for a second, that there were 5 hash marks in the number 7. So this box right here, let's pretend it wasn't blank, that it really had 5 tick marks in there, all right? If that were the case, then I would list out 5 7s down here as well inside my list. And the mode, all right, well, number 4 and number 7 both had 5 collars in it, so then they'd both be the mode. The mode would be 4 and 7, all right, if there were 5 collars who had waited 7 minutes. So, again, mode is most repeated, and it is possible to have multiple modes, all right? If you have multiple data points that are tied for first in terms of most repeated, then they're both the mode. If they're all different, then there's no mode, all right? So, all right, if you have any questions whatsoever, you can put those in the comments down below. I hope you enjoy this. Again, if you got something out of this, I encourage you to hit the like button down below, but also hit the subscribe button to be able to subscribe to the channel. I hope you take you through 7th grade. All right, we'll talk to you soon.